Hi, how are you? My name is Vladimir Toussaint, and I will be speaking about Elm language. Elm language is a functional programming language that compiles to JavaScript and runs in the browser. The purpose is to build web applications, and its main competitor is with React. Um, what makes it a functional programming language is that it has a collection of functions, and you don't have to be a math genius in order to learn Elm. So, in comparison to using methods in object-oriented language, the important difference is Elm functions don't run in the context of an object where they share states with other functions. An Elm function is stateless, so that means whatever the input is, that will return the output with absolutely no side effects. So another benefit about Elm is that it grants you features beyond JavaScript. And some of those features is there are absolutely no runtime errors. Uh, Elm is built for immutability, is built for robustness, simplicity, and it has pure functions as well. So, as I mentioned earlier, Elm does have things such as stateless functions, and all Elm values are immutable as well, meaning that a value cannot be modified after it is created. So, another thing to include is that Elm is has a type system. So, the thing about the type system is that it is to prevent any kind of errors related to data types. So, for example, when you pass an integer into a function that expects to be received in as an integer, but Elm can actually predict and determine the kind of data type without explicitly having to identify what that data type is. And usually, most programs, when you pass this integer and it isn't the correct receiving data type, it will act or behave or explode in an unexpected way. So, static typing means that the actual source code of your Elm program is verified by a compiler. So, what the compiler does, it looks for type related errors, and if it finds one, it tells you loud and clear that there is a problem with your program, and that is why it refuses to build the program. So, these errors at compile time provide a high level of type safety that you should say, which can also be referred to as strong typing. And because Elm does have a strong static type system, this is why Elm can boast that it has no runtime exceptions. So how exactly does Elm and React compete? Elm and React both give you the opportunity to try them out in the browser so you can learn their syntax and how they work immediately. Both Elm and React are installed using npm, and Elm is globally installed and provides its own packages. And the default install of Elm includes the core libraries, HTML libraries, and the virtual DOM rendering engine. As for React, it includes React and the React DOM library. How these two compete with one another is that React, being more popular at this time, has a wealth of packages and libraries available, and it doesn't match the number of jQuery plugins out there, but of course it's getting there. But the advantage of Elm right now in terms of libraries is that the people writing them are already familiar with functional programming and things like type checking. So, because Elm allows type declarations, All packages come with a set of API documentation based on all the type declarations for types and functions. So another advantage is that some of the major React packages included within the Elm's core, such as like Redux, Flux, and Nuclear.js and Immutable.js, there's no need to search for a reactive flow library or mutable object library when the Elm language includes those features by default. So, a few more things I can include is that Elm wins because of Elm Reactor, which is a built-in way to create and test Elm components and applications rapidly. Elm also wins because it has three different ways to integrate components, and all your components can be compiled into one JavaScript bundle, making it easy for you to grow your Elm web app inside of like an existing code base. Ultimately, I can conclude that both frameworks are very useful, but they still have different strengths in completely different areas. So I like to speak just a little bit about the Elm architecture. So the architecture seems to emerge naturally in Elm, and the architecture is actually fairly easy and it is useful in any front end project. In fact, projects like Redux have been inspired by the Elm architecture. So you may have seen certain patterns, but even if ultimately you cannot use Elm at work yet, you can get a lot out of using Elm and internalizing this particular pattern. So, briefly about this Elm architecture, the model is the state of the application, and update is a way to update your state, and view is a way to view your state as HTML. So this pattern is reliable and it follows this very easy process flow so that way you can properly understand the logic of your code and which the way it needs to flow. So right now I'd like to jump into the code for a little bit. So now we have a function here defined as foo, and if the number is greater than 10, then this is just an example code. By the way, we're not trying to print anything here. Now, as you can see here is that there are no runtime errors, but what Elm does is it provides a list of suggestions which is very user friendly of how we can fix our code and correct it. So now what we're going to include is an else here, and we'll include just another string. And as I mentioned here, for this portion of the video, we will not be printing anything out, but we're just looking and focusing on compilation, on whether it does compile or not. And it works. So what we're going to take a look at here now is that a null. So in JavaScript, a null or undefined is usually to represent an absence of a value, but in Elm, it doesn't have any null or undefined, as you can see by the compiler. So now we're going to define our foo function once more, but in this scope, we're going to do something just a little bit more differently. So in this case, we're just going to simply try something a little bit more different. So as you can see, if num is greater than 10, then just the string, or else return nothing. And of course, when we click to compile this, it compiles. And as I said, we're not displaying anything. So as we can see for the first line, int, maybe string. Now, the thing is that Elm does have a type system, as I mentioned. So when the function receives a value, it will determine what that given type is. And we have bar num, case foo num of, just string to string upper, or nothing, and we can also return this as an example. So when we go to compile this, this will compile and raise no compilation errors. And this was just another way to write the code from earlier, just a different way to follow the syntax. So now let's get into why choose Elm. Well, for starters, no one knows all of JavaScript. JavaScript has a large set of frameworks and libraries. And anything can fail in JavaScript because of some sort of oversight. Elm is just plain simple. Builds cannot break in Elm because, as I've mentioned probably many times before, Elm does not have any runtime errors, and during compilation time, it has a user-friendly uh, suggestion system where you can correct the code for more efficiency. And of course, it has a great type system in Elm. Overall, Elm is definitely on the right track. I think that if you're trying to figure out what to use for your next project, you should definitely give Elm a try. You can even use it with existing projects due to its interpretability with JavaScript. And it certainly does have a lot of benefits and long lasting positive effects on a team and its code base. My name is Vladimir Toussaint, and thank you very much.